Okay, so what did Carter do wrong? What did Carter do wrong? He swapped them, right? So he said 1, 5 instead of 5, 1, right? That makes sense? So he swapped the X and the Y. Okay, so the correct coordinates should have been what? For W, what should they have been? I'm sorry, what are the correct coordinates of points W, X, Y, Z? So that would have been 5, 1, this would have been W. Z would have been 4, 2. 2, 4 would have been X, and 1, 4 would have been Y. Okay. All right, so today we're going to represent complex numbers visually using the complex plane. Okay, so here's the biggest takeaway for the next 2 weeks. Okay, I need you to know that the square root of -1 is I, and I squared equals -1. You have to have that memorized. I cannot tell you on the test. You got to know this. Okay, so I squared equals -1, and the square root of -1 is I. 2 things you have to have memorized. Okay. All right. Now, let's use this fact to find solutions to some equations. So find the solutions to these equations, then plot the solutions to each equation on the imaginary or real number line. Okay, so what we're going to do is we're going to take the square root of both of these. What's the square root of 16? 4. And we have that positive and the -4, right? So on the real number line, we're going to graph 4 and -4. Okay. On number 2, we're going to do something similar, except this time when we take the square root, we have a negative underneath the radical. So that means that we're going to have positive and negative. What's the square root of 9? 3. And since it has a negative underneath the radical, we're going to put an I. So the place that we're going to plot that at is up to 3i here and down to -3i. Can you try number 3? All right, so now when we take the square root of both sides, okay, we're going to get positive and negative I square root of 5. Well, when we take the square root of 5, it's roughly about 2.3. Okay, so that's going to go about here and here. Okay, so it doesn't have to be super exact, but it's going to be in between 2 and 3. Okay, so complex numbers is what we've kind of been talking about. Complex numbers have a real part and an imaginary part. Okay, so what I want you to do is take a second, circle all the real numbers, all the imaginary numbers, and put a check beside the complex numbers in standard form. Go ahead and take a moment, try that. Okay, so the real numbers are going to be the numbers without the I. Okay, so real are going to be like 7, -1, 0, and 1/3. Okay, just because 0 is nothing doesn't mean it's not a real number. Okay, my imaginary numbers are going to be -3i, -2i, I square root of 3. Okay, a lot of people forget about this one. Okay, but there's nothing in between the I and the square root. So, right? And then the last one, complex numbers, are all of these. If there's any sign in between a number and an I, that's when you're going to have a complex number. Okay. Any questions on these? I mean, I got all those right. Yeah. Okay. One person, two people. Yikes. 3, 4. Okay, cool. A little bit better. All right, so now we're going to actually graph these. So we're going to plot these complex numbers in the plane. Okay, so if I had 2 plus I, this is how I'm going to plot it. I'm going to start at 0, 0. I'm going to go to the right 2, and then up I. And this is where 2 plus I is going to be. Can you plot these 4? Okay, on this first one, we have -2 minus I. So when we plot this, we're going to go -2 minus I. On the next one, we have -6 plus 3I. So we're going to go to -6 plus 3I. And then we have 5 plus 4I. So we're going to go 5 plus 4I. And then the last one, 1 minus 3I. Okay. So can you tell me the complex number that is represented by A? Can you tell me the complex number that's represented by A, this green one over here? -4 plus 3I. Good. Okay, so pretty easy, hopefully. All right, we're almost finished, so hang in there. All right. So draw the points to represent 2, 2 squared, 2 to the third, and 2 to the fourth on the real number line. Okay, so 2 to the first power is just 2. What's 2 to the second? What does that represent? 2 times 2, which is 4. Okay. And then we have 2 to the third. What is that going to be? Not 6, 8, right? Because that's the same thing as saying 2 times 2 times 2, right? Okay, so that's going to be 8. And then 2 to the fourth, that's 2 times 2 times 2 times 2. What's it going to give me? 16. So we can actually do the same thing on the complex plane. The 2I is right here. These are going up by 2's, by the way. So we're going to go up 2I. Now, on the second one, it's saying take this and square it. So that's the same thing as saying 2 squared and then I squared. Well, what's 2 squared? 4. And we know what I squared is from earlier. What is I squared? But I tell you that it equals. I squared equals what? -1. So it's like the same thing as plugging in a -1 here. So what's 4 times -1? -4. So we're going to plot that. And it's going to go right here. On the next one, we have 2I cubed. So that's the same thing as saying take 2, raise it to the third, take I, raise it to the third. Well, what's 2 cubed? 8. I cubed is the same thing as saying the square root of -1 times the square root of -1 times the square root of -1. Well, we know that if we multiply these two together, that's going to cancel and give us -1. So what's -1 times the square root of -1? Well, this represents I, right? So what's -1 times I? -1. 1i. So this could be simplified to negative 8i, which will be down here. Can you take a second and try the last one? All right, so if I have this, then I'm going to take 2 to the 4th power and I to the 4th power. Well, 2 to the 4th power gives me 16. I to the 4th power is the same thing as taking negative 1 times negative 1. Well, what's negative 1 times negative 1? Positive 1. So 16 times 1 is just going to give us 16. Okay? One thing I want you to notice is how as we increase in exponents, we're literally going from imaginary to real to imaginary to real. Okay, so as we're increasing in power each time, we're going all the way around. So what do you think the 5th power is going to be? If it was real on the last one, what do you think the 5th power is going to be? Imaginary, and it's going to be in the positive, right? Okay. There always is a question either on your SAT or on your final exam that's like, hey, take I to the 100th power. Tell me what it is in simplest form. Okay, it's something obscure with the number. Okay, but if you follow that pattern, same thing over and over again. All right, so you're gonna go to student.desmos.com. I know, the worst. Okay, go to student.desmos.com. This one's not long. Okay, so you're gonna go to that page. Okay, and there are 9 slides. All you're doing on this one is literally moving like black dot onto the target. Okay, take a moment, go ahead and log in. Plus 10i. Okay, so when I move this, I can scroll down. Negative 5 plus 10i. You're gonna drag this black dot. You're gonna go negative 5. So 1, 2, 3, 4, 5, and then plus 10i. That's gonna go all the way up to 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be here. Does that make sense? There you go. Okay, and then how would you know? Well, because the x-axis is the real, and then the y-axis is going to be the imaginary. That makes sense? Last thing I want you to do is on your packet, you're telling me what the muddiest point of today was. So what parts of the lesson activity were difficult for you to understand? What do you need more help with tomorrow? Take a couple of seconds. We got 4 minutes left. So you're writing out 2 sentences, and then you can back up.